Greetings, enthusiasts of cosmic exploration. Since the dawn of humanity, our curiosity has turned to the starry sky, posing the intriguing question: are we the only civilization in this vast universe, or do we share the cosmos with other forms of life, possibly older and wiser? As our technology advances by leaps and bounds, our telescopes capture glimpses of numerous stars, planets, and ancient galaxies, exponentially expanding our knowledge over the last decades. This scientific evolution raises the exciting possibility that more advanced civilizations may have emerged long before our own existence. Immersed in this fascinating journey, we are led down a path filled with surprising discoveries about the longevity of ancient civilizations. As we explore new planets and unravel the mysteries of space, we envision the possibility of finding traces of extraterrestrial cultures that may have flourished and declined unimaginable ages ago. We stand at a unique opportunity to understand the role of cosmic civilizations in a vast and bewildering temporal context. The expansion of our cosmic consciousness not only challenges us to rethink our position in the universe, but also prompts us to consider the possibility of being observed by more advanced civilizations. What can we learn from these potential guardians of cosmic knowledge? The answer may lie in revolutionary scientific studies that are redefining our understanding of time and existence in the universe. In this context, it is worth highlighting a particularly impactful scientific study that promises to illuminate the deepest corners of this intriguing question. By the end of this journey, you will be introduced to remarkable findings that offer insights into the dynamics of ancient civilizations and how this may shape our view of the universe. Get ready to delve into the frontiers of scientific knowledge and expand your understanding of humanity's role in the vast cosmic landscape. Carl Sagan, a visionary astronomer and scientist, immortalized himself through his notable contributions, provoking profound reflections on the fate of civilizations through captivating writings and the iconic Cosmos series broadcasted during the 1980s. In his intellectual legacy, Sagan posed a timeless and intriguing question about the longevity of civilizations, urging us to contemplate whether other forms of intelligent life can not only reach our technological level, but also surpass it. Sagan's unique approach to investigating this cosmic enigma focused on the search for radio signals as a means of intergalactic communication. He believed that an advanced civilization would be capable of sending and receiving signals, indicating technical sophistication and the ability to evolve continuously. In this context, Sagan shed light on the brief period of approximately 100 years during which humanity actively began exploring the use of radio to communicate with outer space. In our short journey as a technological civilization, we have barely completed a century since the discovery of radio, sending signals towards the far reaches of the universe. However, the question that arises is, what do 100 years represent on a cosmic scale? If other civilizations are just a bit ahead in their evolutionary path, they might possess technologies that would truly seem magical to us. Conversely, if they are slightly behind, they may not have yet developed technologies based on electromagnetic waves, perhaps remaining in pre-industrial or prehistoric stages, virtually undetectable to us as civilizations. Thus, Sagan's reflections echo as a call to humility in the face of the vastness of the cosmos, suggesting that our quest for intelligent life beyond Earth is permeated by uncertainties and unique challenges. Understanding the longevity of extraterrestrial civilizations is undoubtedly a quest that transcends the bounds of time and space, challenging us to contemplate the unknown with humility and ceaseless curiosity. We are in technological infancy, taking the first steps towards adolescence, and like restless children, we want to know if there are other children out there about to make that leap into technological adolescence. We must consider this new approach to understand where we are at this moment, and in such a vast universe, the time factor is crucial. In such an immense cosmos, it is practically impossible to find a civilization at a similar stage to ours and close enough to initiate contact. The search for radio signals, long considered universal, was based on the idea that any civilization, regardless of technological advancement, would choose to communicate through this method. However, the landscape has evolved rapidly with scientific and technological progress. Just a century after the adoption of radio waves, we have witnessed a significant transition to new technologies such as fiber optics and innovative projects, including quantum communications through advanced coding systems. With this advancement, the approach to the search for extraterrestrial life has expanded considerably. We are no longer restricted to searching for radio signals. We also explore biosignatures and technosignals. We observe atmospheric gases on distant planets, analyze thermal emissions of potential contaminating gases in habitable exomoons, among other innovative methodologies. This multifaceted approach represents a qualitative leap in how we approach the exploration of the cosmos, expanding our perspectives and possibilities for detecting life beyond Earth. With this broadening of horizons, the understanding has emerged that younger civilizations may be more detectable than older and technologically advanced ones. Civilizations in early stages of development may adopt more visible technologies and generate signals that stand out in our observations. However, as a civilization progresses, it may develop more efficient technologies that allow it to conceal itself, becoming less detectable by conventional search methods. It is crucial to consider that an advanced civilization may choose not to deliberately emit signals into space. They could develop technologies that minimize their emissions, making them virtually undetectable by, for example, infrared telescopes. This perspective reminds us that, much like in nature where more evolved animals may adopt camouflage strategies, technologically advanced civilizations may develop ways to preserve their existence without drawing attention to their presence in the cosmos. Finally, reflecting on these possibilities, we understand that the study of the search for extraterrestrial life is dynamic and continually adapts to new discoveries and scientific concepts. The exploration of the universe continues to surprise us with its complexities, challenging us to constantly expand our methods and theories. The possibility of encountering a civilization at a technological stage similar to ours, with a margin of only about 100 years ahead or behind, is an intriguing perspective and is indeed limited by the capabilities of our current instruments. The complexity of available detection methods puts us in a scenario where, realistically, we could only identify civilizations that are in a technological stage comparable to ours, or with a relatively small difference, such as 100 or 200 years ahead. This limitation is associated with our ability to detect specific signals, such as contaminant gases resulting from an industrial revolution, through emerging technologies. In a hypothetical context, these civilizations could have discovered electromagnetic waves and consequently emit gases that could be detected by advanced observatories, such as the James Webb Telescope. Many have speculated about the possibility of NASA having already found signs of intelligent life, but such information would be kept confidential until there is absolute certainty. Let's suppose, for a moment, that the James Webb Telescope detects contaminant gases, biosignatures, and even technosignatures indicative of urban activities. However, uncertainty persists regarding the developmental stage of this civilization in comparison to ours. This ambiguity raises a significant ethical and strategic question. Should we attempt to establish contact or consider this civilization as a potential threat? The decision to establish contact or not would depend on a careful assessment of risks and benefits. If this civilization is more advanced, we could learn a lot from them, exchange knowledge, and perhaps even establish collaborative partnerships. However, if there is a possibility that they are at a lower technological stage, we could inadvertently influence their development in unpredictable ways. On the other hand, if there are indications that this civilization is more advanced and potentially a threat, security considerations would become a priority. The cautious approach would be to observe, analyze, and better understand their intentions before initiating any form of contact. Ultimately, this hypothetical question highlights the complexity of the decisions we would face upon discovering an extraterrestrial civilization and underscores the importance of addressing these situations with a balanced combination of scientific curiosity and ethical and security considerations. On the other hand, if we encounter a less developed civilization, the opportunity would arise to establish a friendly relationship from the outset, potentially sharing knowledge and fostering a mutually beneficial exchange. This dilemma intrigues us and confronts us with a deep reflection on our position in this vast cosmic scenario. To address these complex questions, we can turn to the study by Dr. Adam Frank and Dror Kif from Cornell University, who propose a mathematical model that establishes a kind of contact inequality. According to this model, the first contact is likely to occur with an older and more advanced civilization. While older intelligences may be rare, they would have a disproportionate influence on initial contacts, and the more advanced civilization would inevitably encounter the less advanced one. Given our relative novelty in the cosmic scene, regardless of the actions we take, the probability is that a more advanced civilization would discover us first, as they have more advanced resources and means to observe us. This perspective raises an intriguing reflection aligned with the unsettling words of Carl Sagan. The idea of space wars between two civilizations is unlikely. The discrepancy in technological advancement would be so significant that there would be no real competition. Instead, the more advanced civilization would be so distant in terms of morals and technology that the need for direct confrontation would be practically non-existent. This suggests that, in the event of a first contact, the more advanced civilization could adopt a peaceful observation approach driven by curiosity towards us, beings considered strange, precious, and remarkably different from them. While this perspective is fascinating, it also underscores the importance of approaching interstellar interactions with caution, considering possible power asymmetries and the influence that more advanced civilizations may exert on those in early stages of development. The idea that most intelligent civilizations in our universe may be older than ours is intriguing and is based on an evolutionary and historical perspective. Exploring this hypothesis allows for considering the relationship between the longevity of civilizations and patterns observed in Earth's history. Throughout the centuries, we have witnessed the rise and fall of various civilizations, from ancient Mesopotamian cultures to grand empires like the Roman and Persian. These societies, initially flourishing, faced challenges ranging from political instabilities to environmental changes, contributing to their eventual decline. In the cosmic context, this perspective suggests that the extinction of civilizations may be a natural norm, with various factors playing crucial roles. Climate changes, natural disasters, wars, and notably, self-destruction through uncontrolled technological advances can be considered elements shaping the fate of advanced societies. Applying this lens to the search for extraterrestrial life, the possibility arises that technologically advanced civilizations in other parts of the universe may have followed a similar path. Considering the vastness of the cosmos and the apparent challenge of finding signs of intelligent life, this hypothesis could explain why we have not yet detected evidence of contemporary civilizations. However, it's worth noting that this is a speculative theory, and to date, we have no concrete data on the existence or characteristics of extraterrestrial civilizations. The search for life beyond Earth remains a fascinating and challenging field as we ponder the possible trajectories and destinies of intelligent societies throughout the universe. The concept of the exponential distribution of extraterrestrial civilizations arises from the analogy with natural and technological phenomena that follow similar patterns, such as the longevity of species on Earth or the lifespan of technological products. This approach suggests that, similar to the evolutionary history of life on Earth, Most extraterrestrial civilizations may follow a life cycle resulting in an exponential distribution, where the majority is older and some persist for extraordinarily long periods. The depth of this perspective goes beyond mere scientific speculation, presenting intriguing implications for our understanding of extraterrestrial intelligence and the potential opportunities for contact. If most nearby civilizations are indeed older and technologically more advanced than ours, the fascinating prospect of learning valuable lessons from these cosmic societies arises. The possibility of interacting with civilizations possessing superior knowledge and technologies raises fundamental questions about how we could engage in a constructive and beneficial manner. However, the mystery persists. If we are potentially surrounded by more advanced extraterrestrial civilizations, why haven't we detected signs of their presence? Physicist James Benford, a PhD graduate from the University of California, proposes an intriguing theory. Extraterrestrials might actually be watching us. As we expand our explorations beyond our own planet, sending probes to investigate other worlds and search for signs of life, it is conceivable that civilizations millions of years ahead of us may have already adopted a similar galactic scale approach. The idea that automated probes could be surveying the galaxy sent by extremely advanced civilizations adds a layer of complexity and fascination to the debate on the search for extraterrestrial life. This scenario raises ethical, communication, and even potential benefits questions that we could gain by understanding the actions of civilizations that significantly precede us in terms of technological evolution and scientific knowledge. Benford suggests that each stellar system, places like low Earth orbits, the Moon, and asteroids, would be ideal for this. Quasi-satellites, space rocks, tracing stable orbits around Earth would be the best hiding spots for spy waves. Today, there are 9 of them. From these locations, they could find the most suitable place for an observation base, as quasi-satellites provide optimal resources such as solar energy and a stable settlement. It is possible that spy probes have been placed thousands of years ago. If they exist and have been there for a long time, it is also not dismissible that they have run out of power and become extraterrestrial relics, akin to our Voyager probes. Benford continues to provide ideas for investigating these spy waves, suggesting the use of telescopes and radio to verify if they are indeed there. The quasi-satellite 2016 HO3 is the most promising, being the smallest, stable, and close to Earth, less than 100 meters to 4,900,000 kilometers away. Many astronomers and astrophysicists support this idea. If there are worlds much more advanced than ours, they probably already know everything about us. If that's the case, they have no intention of harming us or interfering in our development. Eamon Cairns, an astronomer at the Yoder El Bang Observatory, believes that the only possibility of finding them is to look for those who are looking for us, called mutual detectability at our current level of development. As newcomers, we continue searching for our cosmic brethren, and we are getting closer to finding confirmed biosignatures. But to find extraterrestrial relics, we will need more than just observation and efforts dedicated to more specific space programs. And here is our beautiful planet, with an increasingly growing population and, unfortunately, also witnessing an exponential rise in stupidity levels. So I address the few intelligent people left in the world. Don't stop being curious and asking questions. We are at serious risk of being one of the short-lived civilizations that, in this grand journey of learning, takes us beyond the universe. If you enjoyed the video, give it a like and subscribe. A cosmic embrace to all.